So we'll start today's discussion. Uh, Welcome to the week 4 assignment discussion for course titled Principle of Industrial Engineering. Myself Akshay, and we'll be discussing uh, last week 4's content and some assignment questions uh, based on that uh, syllabus. So, as usual, we'll start with uh, a recap of all those 5 classes in the week 4 of the course. So, uh, so for deciding the location of the plant, uh, there are around there are many methods, but 5 are important ones, and two of them, uh, factor rating method and point rating method. These were discussed in the last class. So after that, there are like 2 3 methods uh, on which the discussion will. One more was discussed: break even analysis. So these 3 were discussed in the last session. So after that, we'll discuss 3 more during this week's content. Uh, First was load distance method. So if we had uh, uh, like as the name suggests, it takes into account load as well as distance. Sometimes this is called as population or volume. It depends on what context you're talking. So if it is an example of, let's say, some vaccination type of problem or distribution of some uh, ration or something like that, or goods, so in that case you will consider population versus distance. Whereas let's say if you are a manufacturing company, you have, let's say, m number of factories and n number of warehouses where the output of the factory is supposed to go. So there you'll call it as volume distance method, because then the volume of your finished goods is the criterion. So first we'll talk about this load distance method. So basically, let's take one example so that it will be clear. Uh, so one second, I'm looking for an example. Before going to the example, hmm, yeah, so I think Ganesh has joined. Ganesh, can you just confirm whether I am audible and you can see my screen or not?
Yes, sir. You are clearly with me, and good evening, sir.
Yeah, good evening, Ganesh. So I hope you have gone through the classes of week 4, which is the topic of discussion for today. So
Yes, sir.
I was saying there is one important method of load distance method, uh, which is important in order to decide the uh, location of plant, or you can just say optimization of movement of goods between different plants and warehouses, etc. So uh, Can you briefly tell me what do you understand when I say load distance method?
Yes, sir. I'll just say this. So, so if I'll go with an example, sir. If you
Okay.
don't have any problem.
Yeah, yeah, tell me.
Yes, sir. If there are two factors of inventory stores, so, consider A and B, then we'll
Uh,
get to transfer the equipments from one area of A to the B,
mm-hmm,
I will calculate this distance with respect to the load.
mm-hmm,
So I think it's the thing, and uh, we just consider few coordinates between them.
mm-hmm.
So that's the special thing to calculate load distance between 2 points.
Okay.
Yes, sir.
So, yeah, I think you have got the essence of the method, but more formally, you can define it in terms of, uh, as I said, that load means you can consider it as a population or volume, and distance can be calculated based on the coordinates of various locations that you are considering. So essentially, when you when you do this sort of analysis, you need some sort of measure for distance, calculating distance. So, for example, I'll just take one example. Like this is also a simplification, but you can just so. I think similar example was taken during the discussion by professor. But for the sake of simplicity, we'll consider this type of example, wherein let me just clear it. Uh, Sanjay, can you mute your mic? So basically, uh, as the name suggests, this thing in reality, you cannot, let's say, I'll consider one location at point A, another location at point B. So these can be your factories, and let's say this is your destination C. So from A and B, you need to move to C. So in this case, I'll just use different color. The constraint is, so essentially one can argue that if you want to go from A to B, or let's say B to C, B to C, so can I directly go right? I mean, I'll take the shortest distance possible and I'll just go from B to C. Uh, that is one way of doing it, assuming you will have flexibility of doing so, because in reality, from your factory to warehouse, you can draw a straight line on the map, but you cannot do that. You cannot execute that because there are other constraints. You can transport the goods only via roads, or let's say waterways or airways. So those routes are fixed. Their lengths and scheduling is done separately. That is not in your hand. So there you cannot have such a infeasible idea of connecting these two locations directly. So what you'll have to do is, you'll have to figure out whether, let's say we are talking about a point, so one option could be go to C point in this fashion. So this can be one option. Second option can be go via this route. So this can be second option, and third option, as one can see, you can follow this route as well. Just for simplicity, I'm drawing slightly away lines, but these are overlapping lines. So, so you have these three options. So now the question is, which one will we choose? So as the common sense or the economic sense suggests, because whatever distance you take, it should be minimum as possible, right? Then only you'll have minimum transportation cost, minimum chances of delay, minimum chances of pilferation, etc. So in that case, in this example, we have taken very simplified version. So therefore, all three options might look like same distance, but in reality, it will not be. For example, uh, most of us have used Google Maps by now for going from one destination to another. So when you put your destination and you choose the mode of transport as, let's say, car or bike, then you get two, three options. So there, by default, Google Maps shows you the option, the route, which will be having minimum travel time. So there, the objective is to minimize your travel time, right? Because everyone wants to reach the location faster. So what happens? Sometimes Google Maps will give you the choice where the distance will be higher, but the road will have less traffic and you'll reach faster. So there, the objective is to minimize the time. But when you are selecting any new location, or you're optimizing your uh, movement of goods, finished goods from factory to warehouses, in such type of cases, the time may not be of the primary important. It depends on what type of goods you are traveling or transporting. For example, if you are transporting finished soaps or finished shampoos or hand wash, so these products are not that time sensitive. So in this case, your primary criteria will be shortest distance possible. Whereas if you are transporting, let's say, vaccines or very delicate uh, eateries, like imported plants or herbs for various high-end restaurants, or you can say you are transporting vaccines uh, which can go bad if they are not stored in a certain facility, so which may not be available during transportation. So where your goods are time sensitive, there you will not look at the distance, but you will look at the time. But for this course, we are considering mostly the manufacturing sector, and most of them don't have time criticality. Some of them do have, and there, instead of load distance method, you will consider load time method. But here, for our general discussion, let's keep it simple. Here you can consider load distance method. So as I told you, from A to C, you have three options. So your A is, let's say, factory. This is also factory, and this is your warehouse. So this is your problem. So now I'll use different color for these two, because that will. So now let's say you finalize that, path A is having minimum distance, but now comes the question, because then you'll do the same analysis for uh, factory B, and you realize that from factory B to C, there also exists a path which has same distance as that of path 1. So path 4 and path 1 are of same distance, approximately same. So now you are stuck. Now you are wondering, from where should I source the uh, uh, product to this warehouse? From which factory should I source it? So to avoid this confusion, what uh, we need is another set of parameter, which is load. So then you look at how much factory A is producing. Let's say factory A is producing 100 goods, 100 units per day, or whatever, 100 units per month. Whereas factory B is producing 200 units per month. So then now it makes sense that you will give preference to factory B, because you have more volume to transport here. More volume means more sales and more business. So that does not mean that you'll not take anything from factory A. What you try to do in the reality is, uh, there will be some another warehouse, let's say warehouse D, which will be closer to factory A. So then you take the decision that goods from the factory A will go to warehouse D, and goods from the factory B are going to the warehouse C as shown here. So we'll take one example so that let me just check whether this type of example is there, so that you'll have a good idea. Yeah, so in class we have taken example where you can move only uh, between two coordinates, like from one to, like from A to C, you can only move in straight lines, and that too only at the corners you have to reach first. So that type of thing is there. So if yeah, 1 second. So what you essentially do is for A, you calculate load to distance as let's say, you know, this will be the x coordinate of A minus x coordinate of C, y coordinate of A minus y coordinate of C. I hope you all of you know that this vertical two lines is a mathematical function called as modulus. So what it does is it takes only the magnitude of the number, it does not consider the sign, and then you multiply with the load. Now the question is, uh, what type of load do you take? I mean, sometimes people get confused, so you always take the source. So what is the load coming from the source? uh, so this will be source. So in this case the movement is from A to C, so the source is A, so you take A. Now I'll give you, I mean, if someone doesn't know what this mod function is, I'll give you some example. Let's say I have mod 4 minus 2, so that is mod 2, which is 2 only. But if I have 2 minus 4, the subtraction will give you minus 2. But since it's a mod function, we will take it as 2 only. So uh, mod function only takes care of uh, the sign of the uh, number that is inside the modulus operator. It does not care about the this thing, about the sign. It only cares about the magnitude. Why? Because the quantities that we are considering in the modulus are distance, and distance will always be positive. Distance cannot be negative. So that's why we need to put modulus sign. Now, what will you do? You'll write this distance load number for B as well, and you'll compare them. Whichever gives you higher value, you'll assign that factory to this warehouse. Simple. So, I think this is enough. Uh, Let me just see if anything is remaining here. Pardon me, I think I misquoted. So, uh, 1 second, I'll just confirm whether it's least or highest. Uh, just give me a couple of seconds, couple of minutes. Mm, yeah, so I think I made a mistake while explaining. You'll consider, uh, let's say, here you'll consider the factory which has lower load to distance score. So not the highest, because that will have more cost. So pardon my language. I think I made a mistake while describing the method. It should be least score, not the highest score. So because if you have least score, that means for transporting that load through that much distance, you'll require less transportation cost. That way you can consider that one. uh, is it clear, Ganesh?
Sir, yeah, I just want to ask that. So you are saying that going with the 100 units by a factory is a better one rather than 200 because
Mm.
by considering the cost of transportation.
Yeah.
Yes, okay, sir. So why don't you? So as of you mentioned before, with your sorry for that, but with your wrong, no explanation that why don't we go for this 200 because we get with the more business, right? As you said, but with the consideration of transportation.
Yeah, so actually what happens, uh, in this case, if you transport 200 to this C location, you are basically paying two times the transportation cost, right? So instead of doing this way, the more practical way would be to construct, let's say if you have an option to move the factory or warehouse closer, you do that. Otherwise, you construct one more guest house which is nearby, one more warehouse which is nearby to the factory B, so that uh, what happens, this factory A and warehouse C will be a pair and factory B and D will become a pair. Now that is one way to counter this, because you need to have you need to consider transport costs as well. And this analysis is assuming that wherever you move the finished product, let's say warehouse C or warehouse D, it is nearer to your destination market. So uh, in reality, the decision is not this simple. You just don't consider the least distance and load. In reality, you have to take multiple factors into account. But coming back to this analysis, this is focusing on minimizing load distance product. So that's why you choose A. But as I gave you the other way explanation, the other way, I think the next method does that way. Let me just once confirm because I don't want to confuse again. In the next method, what you do, you sort of follow similar analysis and you calculate one different type of this thing. 1 second. Hmm. Yeah, so I think these methods are essentially, their objective is to minimize the transportation cost and uh, not maximizing profit. Okay, so there the difference is there. Earlier, I assumed we need to maximize sales so that we'll have maximum profits, but these methods assume, I mean, their objective is to minimize the transportation cost or the minimize the uh, movement of the goods. They don't want goods, more movement to the goods basically. So the objective function is different, but you can use any rationale as long as your objective is clear. Uh, so uh, is that, does that answer your question?
Yes, sir. So actually, in reality, that we go for the highest production factory rather than with the minimum, right?
It depends. See, basically, uh, what happens? This warehouse C, in reality, you have to first check how much it can accommodate. I'm not talking about load distance method now. Load distance method is minimizing the load distance product. So that is, let's leave it there. But I'm talking about, more practical way. How it is done is, first of all, let's say your factory is producing 100 units and factory be producing 200 units, and then you go and check how much your warehouse can store. So basically, that is the first thing that you do. Here we assume that storehouse can store whatever your factories can produce, but in reality that is not the case. In reality, warehouse also are having limited capacity. Then second thing you check is from warehouse, what is the distance to your actual target market. So uh, this warehouse C, usually it will be closer to a metro city or a city where your product is to be sold off. So by that logic, you have to decide what. Sometimes what happens, sometimes you don't do this way. Sometimes what you do, sometimes you take 100 from factory A and 100 from factory B, and then you take this factory B 100 somewhere else because it is required there. So it all depends on supply and demand in the end. If the demand for your product is more near the warehouse C, then you'll try to send maximum products there. It doesn't, I mean, the cost etc comes secondary there. You prioritize profits there, sales etc. uh, but here we are not talking about that scene. We are talking about a highly simplified version. So here the objective is to minimize uh, the movement for your load, and that is possible if you move lesser load or you move lesser distance or combination of both. So basically we are doing that only by taking the product. We are finding a combination where your load is moved in lesser capacity at lesser distance. So that is it. And this next method is like slightly complicated version uh, of this, I think. One second. Next is center of gravity method. uh, Let me just see if I can find some example for center of gravity method. So in class, professor has taken one example of load distance method, one numerical. If you can just go through it, you'll realize here though we just write distance as mod xa minus xe and ya minus yc. But in reality, uh, we can, you know, the things uh, need to be considered properly. So, for example, I'll take one example since this is a discussion class. So, let's go with the similar example that professor has taken. We'll just change somehow. So, let's continue this setting only. You have factory A. Let's say you have 4 factories A, B, C, D, and what you did, you calculated their locations. So basically x and y coordinates you found out. So let's say this is 3 4, this is 1 2, this is 4 5, this is 2 6. So these are the geographical locations of your factories. And now you have two options, uh, uh, like uh, usually what people do is, you there are two ways to do it. People take the destination separately, or people take the destination as one of the factory itself. Sir has done assuming source and destination in the same listing. I'll just segregate them, and let's say you have two options of E and F. These are your source factories, and these are your warehouses. So now you have to select, and these are your loads. So basically, loads. So basically, what your factory A produces, how many units? Let's say it produces 50 units, 100 units, 200 units, and let's say 80 units. So this information you know, and you know the warehouses are at, let's say 5 7 and 8 9. So I have taken coordinates in such a way that these warehouses are like not closer. I mean, they are randomly distributed. So now, in this case, what you do? How do you calculate the distance? Distance is xa minus xe, right? In this case, your destination is E, first case. So for E, for E warehouse and for F warehouse. So you can do this way. So now what you do, you subtract XA, which is 3, minus XC, which is 5, and you take a mod, so it is 2, right? Then you add Y, 4 minus 7 will be 3, so mod of it will be 3, and into this 50. So that will give you 5 plus 5 into 50, 250. Again, you do the same here. 1 minus 5 minus 4, you take mod 4, 2 minus 7, 5, so 9, 9 into 100, 900. Here you take this thing between C and E. So 4 minus 5, 1 plus 2, this gives you 600. Then 2 minus 5, 3, 1. So 4, 320. Okay. So now you sum it up. So this will be around 70 and 9, 15, 20. So this is the summation, okay? 2070. I think I have not made any. Yeah, I think the summation is fine. Now you carry out the same exercise for destination F, warehouse F. So now again, going by the same logic, what you do, you calculate A minus F, which is XA minus XF, which is 5, and 4 minus 9 is 5, so total is 10. So here it will be 50 into 10, which is 500. Then 100 into, I'll just write the whole thing, otherwise those who have not attended will get confused. Then again, between B and F, so it will be 7 plus 7, 1400. Then C and F will be 200 into C and F is 4, 4. So it will be 4 plus 4, 1600. Then 80 into 6 and 3, 6 plus 3. So that will be 9, 720. So now you sum it up. It will be 20, then 7, 5, 12, 12 plus 10, 22, 2, 4. Yeah, I think yeah, I think the summation is fine because you have 2000, 3000 here itself. The remaining were 4, 12,000, 20. Okay. So now you see here it is quite clear, right? So see what happens here for destination E, summation is 2070, whereas for destination F it is 4000, almost double. So if you plot, you can do this simple exercise on your own. If you plot these XY points on a graph paper, maybe manually or online also you can do nowadays. And if you plot this, you'll realize that these A, B, C, D factories, if they are located like this, E warehouse E, I'm not doing exactly, okay, I'm just giving you the broad idea. So E will be here and roughly F will be here. So that's why the load distance product summation is higher for F, almost 2 times. So that means this warehouse F is quite far from your set of factories that you have. So these are your factories, right? So now, and our objective here in load distance method is to minimize the movement of your load and distance. So therefore, this E will be a better choice and F is a far warehouse. So you will not take that one. So I hope this makes the discussion clear, and let that confusion not be here. So now, did you understand, Ganesh? Now you
Yes.
understood?
Yes, sir. Yes, sir. So there is this one particular doubt about. So now, by this example,
Yeah.
uh, Would we consider A or D for a better for a with the consideration of load with respect to cost of transportation? What we
Yeah,
should consider, A or D
A or D.
or
Hmm.
B?
See, you can do the same exercise, no? See, now you have the data, right? So let's say you don't have factory B and C. So you just remove these two rows and just take A and D. So now the summation will change, right? For A and D, for factories A and D, if you are considering the warehouse E, so your total will be 250 plus 320, right? So which will be around 570. And for your warehouse F, if you just consider A and D, your total will be 500 plus 720, which will be 1200, around 1220. So here also your warehouse E is quite closer to factory A and D, whereas warehouse F is far. So since your objective is to minimize the uh, transportation cost or loads distance by which the load moves, E will be better choice there. See,
So
earlier the confusion came because I was considering only two source and one destination, right? So this is
yes,
actually very simplified version. Here you can apply transportation minimization as well as profit maximization also, because your distance was same, right? From
yes, sir.
A to C and B to C, the distance is quite similar. Also, in that case, you can go for this profit maximization or transportation cost minimization, both approaches. It depends on your business need, okay? It depends on your priority. What is your priority? Whereas, if you consider more complicated model in which you have four source, two destination, there uh, it it actually gives you a better idea that you need to minimize transportation cost. Correct?
Okay, yes, sir.
Yeah.
So
So
yeah,
yeah.
so I just want to ask something out of the box, sir. Sorry for that, but the thing is, I'm asking about if I have a warehouse which is owned by me, but not the
Mhm.
factory.
Okay.
So from that, from these four A, B, C, and D, and E is my point. E is my warehouse point as a
Mhm.
destination. So from the above four factories,
Mhm.
what element? Sorry, what placement of factories should I consider with respect to the load as well as transportation cost? Because you said we should consider the small amount of loads
Mhm.
because of it reduces the cost of transportation.
Yeah. So
So
yeah,
should I
see,
go
you
with
have
A?
asked no, you have asked a question which is quite relevant also. So
Yes,
you
sir.
need to first understand, here we have taken this, see this, when you multiplied load, when you multiply, distance with the load, it is considered from source, how much load is coming from the source. So now the question that you asked, that you are owner of this warehouse E, and you need to decide out of four factories, which factories you want to take the delivery, right? So see, first of all, for taking delivery, you are not paying anything. You are paying to send goods from your warehouse to next destination, right? If something is coming to your warehouse, the factory is paying for that, right? So usually the source pays for the transportation. So if you are comparing out of four factories, which factory, the I mean the goods from which factory you should take in your uh, warehouse, I don't think the transportation cost should be your concern, because you are not paying anything, you are just receiving whatever is coming. So now your concern will be uh, your own capacity. So this warehouse E, if it has, let's say, see, the total load was 50 plus 100 plus 200 plus 80, right? So it is around 420 units. So if your warehouse has 420 units of capacity, you will accept the goods from all four factories, right? Because that will maximize your utilization of your warehouse, no? But let's say
Yes.
if you have only 100 units storage capacity, so now you cannot take from all four, right? So what you can do, see, you cannot take from factory C because factory C is giving you 200. So you are not having that much capacity. You have three options now, A, B, and D, because A produces 50, B gives you 100, and D gives you 80, and your capacity is 100. So now tell me from which factory will you accept the delivery?
Either of B, firstly, or else D, sir.
Yeah, because
Or
you are,
A.
no, A will be the last choice, right? Because
Last choice. Yes.
yeah, because you will be only utilizing 50% of your storage capacity.
Yes.
So in that case, the factory B will be the best choice for you because they are giving you 100. You can store 100. So you are not wasting your capacity, right? So that will be better choice for you. So I
Yes.
think that will, I hope you got my point.
Yes,
So
sir.
it
Yes.
depends. It depends from where, which point of view you are thinking. So if you change your point of view, if you change your objective function, then everything changes. So then you will have to figure out how to apply these methods there. Okay.
Yes, sir. So, sir, last thing, sir. So,
Tell me.
yeah. So by load distance method, what we're finally calculating, sir? So for I'm asking this because
Hmm.
we by the summation of all the loads with respect to the distance coordinates,
Mhm.
we are summing up lastly, but equal to something which is I couldn't get that quite right.
Uh, are you confused with the notation?
Yes, sir.
No, this is summation symbol. This
Yeah, yeah, I got it, sir. I got that, but summation of so we are calculating this all.
acha, acha, okay. So
Yeah.
yeah, I think what you are asking is, see what happens. Uh, how should I say? Do you know the difference between average and weighted average?
Um,
Do you know
Average.
what is average?
Yes, sir. Average. I know.
So
Average.
if you have, let's say, five numbers, and if I tell you to do the average, what will you do? You'll take sum of them, divide by the total
5.
number.
Yeah.
So that is your simple average. But
Yeah.
sometimes what happens, uh, for example, if you are, what you, let's say, take an example of any cricket team or something. So if I tell you, if I ask you a question that, let's say, Indian cricket team, can you tell me how their form is recently? So what will you do? You'll go back and check on Google that in last 10 matches, how many matches they have won versus how many they have lost, right? So you'll have some ratio. So that is one measure of doing it. But some other person will go home and check last 100 matches and calculate the win by loss percentage there. So which one do you think is a better measure to consider the current form of Indian cricket team? Should you consider last 10 matches, recent 10 matches, or recent 100 matches?
The prayer one, sir. I'll go with the last 10 matches.
Yeah, because that data is new data, right? Recent data. So that will give you the better idea. So you are not taking average by giving importance to all the matches. All last 100 matches, you don't care, right? You only care about last 10 matches. So similar approach. So that is called as weighted average. So you are giving more weightage to the recent matches, results of recent matches. Here, first, by doing this summation in the bracket 2 plus 3, 4 plus 5, etc., you are just calculating distance. But what happens? See, in this ABCD factory, your C factory is the largest factory because it has 200 units capacity, right? So, if it comes to, let's say, I'll give you one hypothetical. See, you did these two summation, right? For E and for F. For example, you got these value as 1000 and 1000. See, in earlier case, we got one as 4,000 something and another was 2,000, right? So we clearly knew that E is the better choice. But now, let's say you did all the calculation and you got 100 as a summation for E and 100 as summation for, 1000 as summation for E and 1000 for F. Now what will you do? Tell me.
I think I'll go for the load.
Yeah, so why did you choose load? Because that is the parameter which is important for you, right? So what will you do if you get 1000 in both the cases? You'll go back and you'll check which factory is producing more units, right? Because that will be important for you. And then you'll consider to move this 200 units, which destination gives me lower cost. So here destination E gives you 600, whereas F gives you 1600, right? So then you'll make decision that E is better, because out of this, how many units do you have, right? You have total units you have 420, right? Whereas factory C only produces 200 out of 420, which is almost 50%. So if you land up in some case where your summation is same, you go back to the highest important parameter, which is factory C, right? So that is the importance of this loads column. You need to consider, basically you are taking average of distance because you are doing summation. You can divide by 4 also, because 4 factories, that will be like average, but you don't do that because that will just complicate your calculation. So this is just you are taking distance average and weighting it with respect to loads. So this is a weighted average method. uh, I hope you are getting my point.
Yes,
We
sir.
are
Yes.
you are giving more weightage where your more load is there, and
Yes.
that should be the logical way, right? I mean,
Yeah.
practically speaking, that should be the way, right?
Yes. So, can you explain the last part, sir, about the total units and the factory C?
Yeah, so see, your total units that you need to distribute amongst any one of E and F are 420, right? How did I get this 420 number? I just add these loads. So 150 plus 200 plus 80. So I think that is 430. Sorry.
Yes.
So 430 is there. And now I look at this 430. Out of this 430, my only one factory, which is C, making almost 50% of it. So I need to give more importance to factory C as compared to, let's say, factory A, because factory A is producing least number of units. So this comes only if your scores are tied.
Yes,
If your
sir.
scores are not tied, then you just go by the usual way. Understood?
Weighted average method.
This is kind of weighted average. And
Yes,
next
sir.
method is also kind of weighted average. Next method is this thing,
Center of
uh,
gravity. Yes.
center of gravity. Do you know what is center of gravity?
So we'll go for the like so as of the of
No, no.
previous example.
I'm not asking about center of gravity method. I'm just asking what is center of gravity. Do you know?
Okay. So I know the gravity will. So we just like 9.8 like that, sir.
Yeah. So that is acceleration due to gravity. But see what happens. Uh, Consider an
Attract
example.
force.
Yeah, that is okay. I'm just giving you an example. Consider a ball. Okay. So ball will be spherical, right? So now if I ask you question, from which point is gravity attracting this ball towards ground? Let's say this is the ground. If I leave this ball at some height, it will fall down, right? But my question is, through which point it is attracting? So what you do, you take uh, you take some small masses in the sphere. Assume that the sphere is made up of very small masses of m, and you take the volume average and divide by total volume. I think this is I mean, I think I have not explained it properly, so I'll take some other example. uh, how should I explain? Let me give you one example. uh, hmm. Mm, See, center of gravity is defined as an imaginary point in a homogeneous or heterogeneous body, whatever, but it should be a body, not a point source. If you consider a body, then center of gravity is a hypothetical imaginary point through which the gravity exerts its force on that body. So in case of sphere, it is the center of that sphere. For any regular, like any spherical or cuboid or something like that, for those objects it will be the center. But if I give you, see, consider the same example. Okay, this is the ground, and if you have some body like this, and this is like a triangle, okay, and it is resting on the ground with its one face touching the ground, whereas I give you one another body is like very small shaft, and at the top you have a very heavy mass. So tell me one thing, from, let's say, and then I try to disturb this, I go and just push them, both these bodies. So which body do you think will fall quickly on the ground?
Yeah, obviously the second one with the ball.
Yeah, so the reason is, for the triangle, if you assume it is an equilateral triangle, the center of gravity will be at this point where all the angle bisectors intersect. Whereas for this body, the center of gravity will be somewhere here at the center of this sphere. So basically, this is more stable structure and this is less stable structure, right? So if you use the same analogy here, so what happens? Let's say you have four factories like this A, B, C, D, and now you have a choice. You are a CEO of the company, and you want to make a choice that where you want to put the warehouse. So I'll give you two, three options. You just tell me where you'll put it. First option is, I'll give you, this is my first option. I'll put warehouse here. Second option is, I'll put my warehouse here. This is my second option. And third option is, I'll put it here. And fourth option is again some random here. So now tell me, where should I put the guest house? And these A, B, C, D are my factories, okay? So can you tell me, logically
Yes,
speaking, leave the
y-
center of gravity, etc. away?
yes. The three, because each of the factory could have the same distance.
Hmm.
Yeah, three.
Yeah. So see, intuitively you land up at the correct answer, because you can see, right? See this plant. Sorry, choice A. It is farthest from A and C, and far from A, B and D also. It is not like very close to B and D. Coming to second option, it is close to A and C, but it is far from B and D. But this 3 point, it is like equally distance from all four, right? So then you understand, if I put my warehouse here, uh, my total cost of transportation will be very less, right? So we'll take same example as we gave here, four factories A, B, C, D. A, B, C, D, and same XY coordinates. So we'll get 3, 4, 1, 2, 3, 4, 1, 2. I think 4, 5, and 2, 6. So we are taking the last example only, but now the question is different. Now the question is not that you have two options. Now the question is, you yourself are going to create one warehouse. So where you want to put it? Correct. So now there is a scientific way of doing it, which is similar to calculating the center of gravity of a body, and therefore the name of this method is center of gravity method. So in which, what you'll do, you just use a simple formula. in which, let's say, your warehouse will denoted by E. So to calculate the x coordinate of E, you'll just, what you do, we'll just use L symbol for load, Li into xi divided by total Li. So, and I goes from 1 A, B, C, D. So, do you understand, Ganesh, what I have written here?
Yes, sir. The load and the distance, right?
So this is again weighted average, right?
Yes, sir.
Because you are not simply taking average of load, you are taking weighted average with respect to distance. So if you do this calculation, just multiply x by this thing. So for A it will be 3 into 50. For B it will be 1 into 100. C it will be 4 into 200. D it will be 2 into 80. Divided by total load is, I think we did the summation earlier, 430. So this will be 150 plus 100, 250. 250 plus 160, which will be 410, and then 800. So it will be 1210 divided by 430. It will approximately, it is 3. Okay, I am not doing exact calculation. You can do that. It is just a calculator thing. And you again calculate y coordinate. Similarly, same formula. Instead of x, you get y. So there it will be 4 into 50 plus 1 into, 2 into 100 plus 4 into 200.
1880 by 430, sir.
Oh, you did a. Okay, I'll just write it down. So what is the final value?
Uh, Wait a minute, sir. 1880 by 430.
1880, yeah. So it will be around 4.5, I think.
Yeah, sir. We just go for 5.
No, 1880, no. So it is less than 5 because 5 is 2000. So it should be 4.5 around.
Yes, sir.
1880 divided by 430. Yeah, 4.4. So let's say 4.5. So now you understood that if you put here your warehouse at location given by EX and EY, which is X is 3 and Y is 4.5. Ganesh, if you have free time, no, what you can do, plot these 4 points on graph and plot this point which we calculated from this calculation. What you will realize is, see, ideally speaking, if these A, B, C, D are like this, I'm not considering their X and Y coordinate, okay? So don't take me that way. So ideally speaking, what you will feel is this ideal location for warehouse should be at the center, right? Here somewhere. That is your ideal location, right? For your warehouse. But
Yes.
if you plot these 4 points on a proper graph paper and then plot E, what you will realize is in reality, uh, if you consider this again same A, B, C, D, then see the factory C has the maximum load, and after that B. So like if you do the decreasing order of load, C is having highest load, then B, then D, and then A, right? So this is load. So ideally it will be closest to C and farthest from A. So it will be somewhere here. Somewhere here because B is also strong, right? So see, you can understand this way. Whichever has higher load, that will attract the center of gravity towards it. So In this case, A has the lowest load, so A will be farthest, C will be the strongest pulling factor, but B and C are diagonally opposite, right? So it will be closer to closer to C, like between B and C, it should be closer to C and D. So it will be somewhere here. It will be here. So it will be E actual. Did you understand, Ganesh?
Yes, sir. Yes, sir. It's nice, sir. Thank you for
Yeah.
that. Thank you for
Yeah.
this.
And now you understand, right? Why? Because your factory C produces the maximum number of units. So the warehouse should be closer to it. Common sense tells you that, right? So
Yes, yes,
this
sir.
method also tells you that only. So if you have free time, you can just plot it and see for yourself. So now
Yeah.
this is center of gravity. So basically the center of gravity and the earlier method, which was this load distance method, these are weighted average methods. Okay. And then there is one more method. I think it is the sixth one and the last one.
Sir.
Yeah, tell me.
Yeah. So, so in load distance method, you said that we should go for the uh, minimum load factory, right?
Hmm. Yes.
So here E actually showing towards C.
Yeah.
So could we consider the maximized, sorry, not maximized, higher number of load because C is the better choice.
No, no. Actually, see, in that earlier method, uh, the objective was minimizing the transportation cost, right?
Okay.
Uh, and here also, sorry, yeah, I'm correct. The earlier was minimizing the transportation cost, and here your objective is to find an ideal location for your warehouse. So tell me one thing. You can look it from transportation cost also, but that will confuse you with the previous method. That's why I did not use that terminology. Uh, but tell me one thing. Let's not compare four factories. Let's just compare uh, this thing. Two factories, A and C. A is producing 50 units, C is producing 200 units, right? So in earlier method, you were not having the flexibility to choose the location for your warehouse, right? Warehouse was fixed somewhere. Now you had to decide which factory, if you transfer that goods from, will give you the minimum total cost, right? That's how you did the earlier case. But here what you do is basically you find a point E between A and C where your transportation cost from A to E and C to E will be almost similar. Uh, do you understand?
Yes, sir. Yes, sir. I'm getting.
So here, uh, instead of transportation cost, you can understand this way. Uh, how should I put it? I can give you one practical example. Since it is a center of gravity thing, again, I'll have a structure like this. Okay, cross. It is a welded cross, and I put a small mass here, a slightly bigger mass here, then slightly bigger mass here, and the largest mass here. So even though graphically this is the center of this structure, but from point of view of gravity, can you tell me where the center of gravity will be? See, gravity essentially is an indication of mass, right? So if your system is heavy, more gravity will act. That is mg, right? Mass into 9.8 you do. So in this case, even though this is your geographical, not geographical, geometrical uh, center, your actual center of gravity will be somewhere here. Can you imagine?
Yeah, yes, sir, sir. Yes, sir.
Yeah, because the more mass is that this side, no? So
Yeah.
similar way of thinking needs to be applied in this ABCD case. Your A factory was having minimum volume, C was having maximum, right? So eventually you should select a warehouse which is closest to your factory, which will produce more number of goods. That will give you minimum transportation cost.
Okay, sir. So all these methods for selection of sites, consider transportation cost. Is it right, sir?
Ah, yeah. So whatever we are studying here, eventually it comes down to the cost. And since it's a location of plant, location of warehouse, in these examples, uh, the transportation cost becomes the most important category criteria. Sorry, if it is like in the next case we'll discuss, right? I'll give you just hold on for 5 minutes. I'll just explain this one. The sixth one was this return of investment method. Uh, this term is purely economical. It doesn't is the short form is ROI. So if this is actually used in terms of this stock market terminologies, basically if you buy shares of company A using your 1 lakh rupees, and after 1 year, if the value of that investment goes to, let's say, 1.5 lakhs, so your profit will be 1.5 minus 1, which will be 50,000. So what will be your return on investment? 50,000 divided by your initial 1 lakh, right?
Yes, sir.
Are you with me?
Yeah, yes, sir. I'm with you.
Yeah, so basically, if you invested 1 lakh rupees today and after 1 year you are getting 50,000 as profit, then that is your returns, right? Returns means profit. So that will be your ROI, returns on investment, will be 50,000 divided by 1 lakh into 100. So that will be 50%. So this is pure economic terms. And now your question will be, how do you use this to do the
Site selection.
site selection, right? So what you do, again, if you have ABCD, you don't consider volumes directly here. You consider those things indirectly. How? So basically, if you have factory A, B, C, D, what you do purely economical analysis. You don't care about transportation cost as much. You care about the total cost, not only transportation cost, but all manufacturing, like production cost, transportation cost, etc., etc. So how will you go about it is, first of all, you'll decide what is the initial investment for all these four. So now, can you tell me the most important criteria that will affect your initial investment if you have four factory sites to choose?
Sorry, can I get sorry? Come again, sir.
My question is, you have four sites, okay? Let's say one is in North India, one South, one East, West, okay? Four sites, and
Okay.
you want to put four factories there. So initially, what will be the most important criteria for you for initial investment? What will be the first thing that you look at?
I'll go for the market.
Uh, See, market is distributed. I understand your argument, but market is not focused. Uh, it is pan India. It is something which is used all over India, right? So,
Uh, Area, sir.
so land, basically land cost.
Land.
So the one of the important factor is land cost, and that comes under initial investment. All other things you'll look at later. If your product is not, if it is all India product, let's say if you are making Lifebuoy soap, so whether it is North India, South India, everyone it is used, right? So your market is everywhere. So now in that case land becomes important. So initial investment includes land, mostly land and other legal taxes, etc. Those things are there, which are like fixed cost, you cannot do much about it. Then you'll do this thing. This will be your initial investment, right? Some numbers will be there. Let's
Yes.
say we'll put some numbers: 2 lakhs, 4 lakhs, 6 lakhs, 5 lakhs. These are all lakhs, okay?
Yes.
And then what you do, you then, so this is your initial cost. Then you go next, and then you study that locations. You do some market survey, etc. And then you realize that for distributing that product in from there, uh, let's say from A to your destination markets, uh, it will have some transportation cost, it will have some production cost, right? So that all will come under uh, expenditures. Okay, so expenditure means if you want to produce something there, how much you have to pay extra more than your investment, because investment is only for land, right? After that you have to put machines, you have to hire labor, you have to take power connection, water connection, you have to do the wastewater treatment plant building, etc., etc. You'll have salaries, etc. So those all expenses will be counted for all four sites. And these are like image, like, I mean, these are not exact numbers, right? Because you have not constructed four factories there. You are just
Okay.
doing some market survey. You are asking your friends who already have plants in that location that how much does it cost, etc. And then you get these number. Let's say 5, 2, 1, 8. So I'm talking, let's say, on a yearly basis. These numbers will change, right? See, initial investment will be fixed, but these expenditures, they will be a function of time. So uh, do you understand? These are
Yes,
not
sir.
fixed. These are will be per unit time, these numbers.
Annually, we'll get variations.
Huh.
Yes.
Annual, let's say this is annual expense, okay, for
Yes, sir.
simple calculation. And now finally coming to the important for any important for any important part for any organization is what is the revenue that you generated after doing all these things. What is the revenue that you generated? So let's take some hypothetical numbers, 10, 7, 12. Okay. Now this revenue consists of the decision of, where to sell it, at what price to sell it, all those things. Like we did the break-even analysis, right, last time. So all these things will come into picture there, and you finally got some revenue, and it is same annual revenue. Okay. So now, uh, now you have to take a decision as to where should I put. See, now you understand the transportation cost, etc., etc., all are included here. They
Yes,
are
sir.
not labeled as transportation cost, but they are coming under expenditure or
Expand.
initial. Correct.
Yes,
So
sir.
somewhere down the line they are coming. So this basically takes considers everything in terms of money, but that numbers are calculated as assuming all other things that we earlier studied. So now what you do, you cannot decide this way, right? These numbers are not giving any sense. So what you do, you calculate this return on investment for each site, and that formula will be revenue minus expenditure. My iPad is behaving improperly. The letters are coming late. Anyway, divided by initial investment. Do you understand why we defined it this way?
Yes, sir. So this revenue minus expenditure is all about profit or the gain we got.
Hmm.
Yeah.
This initial investment is your initial capital. I told you this example of stock market, right?
Yes, sir.
So same analogy is used here. So now you do this calculation. Can you help me out here? Because otherwise it will take a lot of time.
Yes, sir.
Uh, just give me 1 second. I'll change these numbers. One important thing that I need to show. Huh. So now the first one will be ROI for A will be 4 minus 5 divided by 2, which will be
Minus.
minus 1 by 2. So minus 50%. So see, one difference here you should know is here we don't change the sign. We take whatever sign comes,
Yes.
because If you are positive, that means you are in profit. If it is negative, that means you are in loss here. Now in site B, it will be 8 by 4, so 200%. In site C, it will be revenue by, it will be 100%. And in site D, it will be 4 by 5, so 80%. So now tell me which plant location will you finalize?
Obviously, with the B.
Yeah, so this method looks very simple because you are doing one simple calculation, right?
Yes, sir.
Profit by initial investment. But it is not that simple because these numbers that I gave randomly, they don't come randomly. You have to do a uh, lot of
Research.
research and hard work for these. But this method gives you a criteria to just look at one number and decide. So therefore, plant B will be your uh, suitable choice. Understood?
So, yes, sir. As a business entrepreneur mindset, mostly towards gaining the profits, right? So, could I go for this method irrespective of other things?
Mm, see, everybody, like most people use this method only.
Okay.
Uh, if you are wondering what actually is done in the industry, this is only, I mean, this is what they do. But see, it is, I'm telling you again, it is not as simple as it looks because you are, see, these revenue numbers, see, initial investment you can predict up to a good certainty, right? Because you know the land price there, you know how much, taxes, etc., construction cost, all those things you can guess correctly. But when it comes to expenditures and revenue, things are tricky because these are variables, right? These are unit of time. So, uh, see, we are taking this on annual basis. But if you do this calculation for monthly basis, then you may get, maybe this factory C will become better choice because in location C, you are able to sell more product during the initial months because that market is not that explored, but it saturates after some time, or it is a seasonal market. You understanding? So,
Sorry, sir. Could you repeat again?
so see here, B and C are the obvious choices, right? Because one is giving you 200% and other is giving you 100%. But these numbers are for 1 year, right? What if
Okay.
I ask you what will happen after 10 years? Which site will be better? So as far as the guessing of these numbers of expenditure and revenues goes, you can do a good projection for 1 year, right? But for
Yes.
next 10 years you can't do the projection, right? Because you don't know what will happen in 10 years. Something like COVID comes in between, all your projection will be gone, right? So
Yes.
uh, even though this method looks quite easy because all the numbers are given to you, it is not as easy as it is to be, for example, if you do some startup, uh, what happens this, if you, I don't know if you have seen this, Zomato, Swiggy, all these businesses are not yet in profit. The reason is, I mean, what their management team says is, we are looking at 10 years time, 15 years time to become profitable. So in 5 years we'll not be profitable, but in 10 years we'll be profitable. So that is how they are operating. It is right or wrong, nobody's, I mean, nobody can judge that. They may be right, they may be wrong, who knows? But it depends on which type of industry you're talking. So if you're talking about startups and all, it is very difficult to do this expenditure and revenue calculation. But if you're talking about some business which is quite traditional, like warehouse business or automobile manufacturing plant or automobile selling plant, selling distribution center. So these businesses are quite uh, traditional, right? You'll have enough data, you'll have enough market survey data to do these projections. So coming back to your question, it is, I mean, you can use this analysis wherever you want, not only for this course, in your life also, for any investment you can use, but it is difficult to do the projection of revenue and expenditure because they are function of time. So, and that is not, because nobody has seen the future. So whatever people are telling, like whatever you are guessing may go horribly wrong. So if you consider that factor, then it is okay to consider this.
Yes,
And
sir.
usually this is what is done. From my experience, I know. Uh, if I can tell you, see, there was. I'll give you one example. Consider my drawing is not good, so I'm drawing our India map like this. I mean, just bear with me. It is not at all correct representation, but this is north, south, west, east. Okay. So I was working in a company where they had one plant in Haridwar, and that plant was very huge. So I'll just denote it by big circle. Okay. And they had smaller plants in west and east, and they had very small plant in south. Now, uh, but the problem was this. This is production, okay. The, uh, and the demand, it was higher in south and let's say west, but demand was smaller in these two areas. Demand, and this is production. So now what was happening was they were producing more in North India and they were selling more in the south and west part of India. So then obviously everyone was asking this question, that why are we doing this way, right? Because it makes more sense to produce and sell more products in south and west part, right? Why are we producing more in north? So can you guess why this was happening? This is a real problem, okay? This is not imaginary thing anymore.
Yes, sir. I can. So, considering the land and the raw material they are getting.
Yeah, yeah. So that was one important consideration, because in the Haridwar there was a tax break, and the land is also cheaper there. So land was cheaper, and state government was giving tax break. So initial investment was very low in the North Indian location. Whereas compared to South and West, the initial investment was high. That was one part. Then uh, the other part, can you comment on the transportation cost? Will it be high or will it be low for this business model?
I think so. Can I know the product, sir, so that I could have a
Uh, yeah,
slide
the
8?
product was not that critical. Let's say it was a soap manufacturing plant.
So then fewer containers are needed for the large amounts of products. So I think a medium type of cost to to produce all around the sorry to transport all around India. I
Okay,
think
so see, yeah, I mean you are going in the right direction, but I'll just summarize because we are already at 8:30.
yes.
Uh, See, this decision of producing more in the North India was taken based on the initial cost, and they assumed that we'll produce more in North India, and then the the discount that we are getting from initial investment, that will be compensated for transportation, because when you transport from North India to West and North India to South, this transportation was done by road because it's a soap product. So as long as initial cost to put a factory in North India is less than transportation cost from north to west, south. will leave east because east was producing as much as it was consuming, right? So whatever it was producing, it was going there locally. So we'll not bother about the East India part. But from North India, major chunk was going to West and South because in North India demand was not much. Demand was very small. So as long as the initial cost is lower than the transportation cost, this model is feasible, right? You will get good profits.
Yes, sir.
But what happened? Let's say 5 years. After 5 years, what happened? The initial cost, that is okay. That is there, right? But this transportation cost is a function of time, right?
Yes, sir.
So what happened after 5 years? The transportation cost become more. It got costlier because the trucks that were carrying that product, they demanded more charges. The warehouses in which these products were stored all over the West and South India, they demanded more charges. So after a point, this initial cost benefit was not sufficient enough to compensate for the increase in the transportation cost. So finally, I mean, that is the time when everybody was asking this question that why are we doing this way? But when people looked at history, then they realized, okay, initially it was cheaper there, now it is not. So what they did, they reduced the production capacity in the north and they put up one more plant in southwest, which is
Oh,
closer to the south and west markets. So
yes.
this is how it is done in practical applications, and they use this method only, this expenditure ROI in the end, because these are all projections for 5-10 years, and you just you use your best imagination. The most experienced people will do these things in the factory in our company. People like us did not even do this part. The people who have experience of 10-15 years, they only do these projections, etc. So
Oh.
that is how it goes.
So, sir, sorry to disturb, but so in between your saying, I got hit with this idea that why don't this production of soap, sorry, company go with the their own containers as well as their own warehouses in south and west, towards south and west, instead of putting a large production house in west and south, sir. Is it a better idea for putting a warehouse as well as containers? Because transportation cost compared to the production house could be low, right?
You cannot say that. If it is that, then it makes sense to do that way. But see what happens.
I
Uh,
said this because in the beginning you said that in south and west there are no tax breaks, as well as the initial cost is high with due to the area because the land cost is higher, right? So that's the reason I said got this idea.
yeah, that is. See, the idea is good. I'm not arguing there. My
Okay.
point was, uh, see, basically you are saying, when this model becomes obsolete, like the tax break and all doesn't happen. So is like what they did, they shifted production capacity to southwest. So you are saying shift the production capacity southwest as well as do the transportation on your own.
No, no,
And
sir, no, sir, no, sir.
then
So I'm saying that so instead of getting a bigger production house in south and west,
hmm
so why don't we? Sorry, why don't that particular company have their own warehouse as well as their own transportation containers, like higher vehicles like trucks, as well as fewer shipments like that.
see, uh, that is on paper it looks good idea, but in reality, whatever expertise this company has, they are of how to make the soap or the product. they may not be expert in logistics, because logistics in itself is a different industry. So, for
Yes.
example, see, you must have heard this Speed Post, DHFL, all these things, right? Courier services. So they are expert in their own domain. So usually, people focus on their expertise, because if you see, you are already investing much more in doing, new production or warehouse facility in Southwest, and along with that, if you want your own containers, then it becomes different business. For that, you need different expertise. Tell
Okay.
me one thing: the person who has made soaps for his life, 10, 15 years of his life, can tomorrow that person do the business of logistics?
No, sir, I could not say that. But if he's diversified like Adani and Ambani like that, he may not. He may available for that.
Not a good time to talk about Adani, by the way. Anyway, so
Yes.
see, diversification is always good. And what the Adani business model was, that only, that they wanted to do complete what.
Monopoly, right?
So, but see, it works if you are smart about it. So what you do is basically you hire people who are expert in logistics and let them do the logistics business, and people who are experts in making soap or manufacturing sector, let them do that business, and
Yes.
you organically grow the organization. What
Yes.
some business houses has done in India is they have, I mean, I don't know why, but they are doing it very fast. This is now not how businesses grow. They need some time to develop. So anyway, uh, so we'll not go there. That is not the topic of today's discussion. But I hope you got my point from this example, that in the end, you use return on investment calculations only, but whatever methods we discussed before this are not useless. My point is, those methods are in a way incorporated in these four heads. They will come somewhere in expenditure or revenue. This transportation cost, na, that will come in expenditure. So essentially, you are using all the methods, but in the end, you basically focus on cost. Whichever
Yes.
option gives you higher profit, you go with that. And over the period of time, if that situation changes, you make changes to your organizational structure. That is how it goes.
Yes, sir. So, sir, last one. So, what is overhead cost, sir?
Hmm. Overhead cost. Let me just check, because I have some idea. I don't want to give you wrong idea, because it varies from industry to industry. Okay.
Okay, sir.
So basically, overheads are not direct costs. I mean, see, if you have a manufacturing plant, uh, uh, the the office supplies, uh, will you consider it as a direct cost related to your business? No, right? I mean, office supplies or tiffin services, these are services which are required for your employees, and
Oh,
in
okay.
in a way
So,
for your organization, but they are not directly for your business. uh,
okay.
See, one great example will be, sometimes you must have seen, if some people are working in a factory or somewhere, uh, some bus will come in the morning to pick them up, and bus will drop them in the evening. So
Yes, sir.
this bus service is not directly linked to their manufacturing, right? But it is essential for employees to reach the factory. So this will come under overhead cost.
Okay, sir. Somewhat like auxiliary help,
Ha,
like that.
ha. Yeah, so which are not directly related to your main production of goods, but
Yes.
they are important. You need to consider them. For example, HR, human resources, they don't do the job of manufacturing, right? But they are important because they manage your human resources. So they
Yes.
will also come under overhead cost.
Yes, sir.
Understood?
Uh, yes, sir. Clear. Totally clear with that.
Okay, so actually there should be, I mean, we should have discussed next part. See, these six methods are discussed, and that discussion is over. Next was type of layouts, but I think we are over the time now. Maybe we'll
Yeah.
discuss next time.
Yes, sir.
Okay.
Yes, sir. It's a wonderful session with you. Thank you so much, sir. I got so much knowledge about it.
Yeah. Thank you for attending, and see you in the next class. Okay.
Definitely, sir. Thank you so much. Good night.
Okay. Good night. Bye. I'm disconnecting now.